guys, today we're going to look at example number 3 and 4 for Coulomb's force, which is more difficult than that. Okay? Okay, let's say you are given, let's say 4 charges. Okay, 4 charges. Okay, example 4. Find the net force on Q4. You have Q1, 2, Q2, -3, and then Q3, 8, and then Q4 is 5. The distance between here is 30 cm and this one is 40 cm. So find the net force on Q4. So that means we only draw the vector of forces on Q4 only. Alright? So the first step that we do will be labeling all the forces happen on Q4. So number 1, Q1, Q2 repel. So your Q4 will experience one force like that, and we label this one as 4-1. Okay, 4-1. And then from here, this one is attracted, but it is attracted following this line. Okay, so this one is F42, right? And then next one is Q3, positive and positive, so repel. So that means your Q4 will repel outwards at the same time. 4, 3, so you have 3 forces. If you look at this carefully, F41 is horizontal and this one is vertical. So these 2 forces is the easiest one to manipulate because they are vertical and horizontal, which we don't have to calculate any component for them. But for F42 is a little bit of problem there. So what we need to do on F42 is we need to split it into 2 components. One is the horizontal and the one is the vertical. So that is like that. Okay. So and we need an angle here. This angle theta. This angle theta is the same as here because of the zigzag property. Alright. So the next step is calculate the magnitude. Number 1 label already. Okay, already labeled. And then number 2 is to calculate the magnitude of all the forces you have labeled. So we start with F41. Okay, so the F41 is equal to K Q4 Q1 over R41 squared. Right? Put in the value K, and the charge is 5 microcoulomb, and this one is 2 microcoulomb at the distance of 40, 0.40 squared. Then you calculate, and then the same thing for 42. Okay, 42, and it is K Q4 Q2 over R42 squared, and the value is Q4 is the same, 5 microcoulomb, and Q2 is -3 microcoulomb, and the distance here is what? 30, 40, 50, according to your uncle Pythagoras, 0.50 squared. Okay, and the last one is your F43. Q4, Q3 over R43 squared, and you have this, okay, 5 microcoulomb and 8 microcoulomb divided by a distance of 30, 0.30 squared. So this one in Newton. Right? So you need the help of calculator to solve the forces. And this one is 8.99 tau 9 multiplied by 5 negative 6 multiplied by 2 power negative 6, okay, and then divide by 0.4 square. So we have this 0.562 Newton. So remember the micro, don't ask the same question again. Okay, next one. Divide by 0.5 square, we have this 0.539. Okay, and last one is times 5 minus 6 times 8 power minus 6, and then divide by 0.3 square. So we got this 4.00. Okay, we round up 4.00. 3 significant figures. So step 2 done. Alright. Step 3, we vectorize them. Okay, vectorization. Okay, vectorization. That means we are changing them into vector form. Now, the F141 and F43 is the easiest one to change to vector form, so we do that first. F41 is pointing to your right hand side, that is positive I. So we have 0.562 I Newton. One done. Okay. Number 2 is this one, F43. F43 pointing upward, positive J. So our F43 here, that is 4.00 J Newton. And then the F42 is a bit different. Okay. So for F42, we have to draw another diagram just to show how we are going to split it into 2 components. Okay, like that. This is our F42 and the angle here is theta. So we have 2 components that we need to find. One is this horizontal component, we call this one Fx, and this one is the negative vertical component, which is Fy. Okay. Now our Fx is equal to F42 cosine theta. Okay, so that means we need to find the theta value. So we come back to here, we calculate the theta value for this triangle. Look at this triangle. You have this 30 and 40. Okay, so we can calculate using tangent theta is equal to 30 over 40. Right, so 30 over 40, and your theta is, it should be 36 point something. Tangent 30 divided by 40, 36.87. Okay, 36.87. So now we're going to use that value into our calculation here. So the F42 is 0.539 cosine 36.87 theta, 87 degree. You got 1. Okay, another one is a Fy, which is F42 sine theta, which is 0.539 sine 36.87 degree. Right? So that is our component. Now we go and calculate the value for them. Number 1, 0.539 cosine 36.87. Alright? So I get this 0.431. Next one is 0.539 sine 36.87. So we have 0.323 Newton. Okay? So that is our value for the component. So that means our F42 is equal to this vector plus that vector. Okay? So we have Fx plus Fy. Our Fx is this one, 0.431. But you have to differentiate the direction. Your Fx is pointing to your left hand side. So we have an I which is negative. See or not? So that means we have negative 0.431I, and then plus another one which is pointing downwards. You know, pointing downward, that one is negative J. So that will be negative 0.323J Newton. Right? So simplify. We have negative 0.431I minus 0.323J J Newton. So that is how we solve that part. Okay, and then the last part, of course, is to find the net force. So the net force is F41 plus F42 plus the F43. So what do we get here is everything go in. 0.562I plus this one, which is minus 431I and minus 0.323J, and plus another one is the last one, 4.00J. Now, we only combine the same component, I with the I, J with the J. So these two will be minus. Okay? So we have for our I component 0.562 minus 0.431, and you get 0.131I, and last one is 4 minus 0.323, and we get plus 3.67 or 68 J Newton. Okay, so that is our answer. Alright, so that is example number 3. Okay, so next one will be example number 4.